Hello everyone, this is Arun. Welcome to Smart Interviews YouTube channel, your one-stop solution to ace all your tech interviews. Today we are here to solve the latest CodeChef contest 170's Div 4 problems. Without any further ado, let's begin. So let's start with the first question, access code equality. So access code equality, the question is here. The question links will be provided in the description. Make sure you read the links. Make sure you navigate to the links and read the questions and attempt them before directly looking at the solution. And yeah, let's start. If you're going to attempt the question, pause the video here, go there, attempt it, come back. Now, starting the question. So you're attempting to join the web club 𝗍𝗏𝗃𝗃's exclusive online session. To do so, you need to enter the correct access code. The correct access code is given here and it is mentioned without the quotes. The code entered is given by the string s, which has length 7. Your task is to verify whether the entered code s matches the correct code. If it does, print welcome to the club, otherwise print access denied, and that should be as per the expected format. So the input format says that single line with 7 characters. Output format says that you can print access denied in a mixed casing fashion. You need not mention only the access denied as given. But in most questions, you might not be given this privilege. So we will stick to printing access denied in the given format. Constraints, nothing much to look here in the constraints, and the sample input output are self-explanatory. So without any delay, let's start with the code. This is my default template I have stored for CodeChef here. Uh, you can do the same by using the save template option. In CodeChef, we usually have the test cases. So I used it to simplify my time taken to code. You can do the same as well. But here we are having a single string input. So you can do it using scan next or scan next line, both work fine. If s is same as the given string without the quotes, then I need to print whatever is specified here, the welcome to club. So to not miss out on any casing or characters, I'll just copy and paste the same thing provided from the question directly. Otherwise, I need to print system out println, I need to print access denied. So let's run it. Let's see what could be the mistake here. Why are we getting access denied? Well, the issue is with the double equal to. We do not have a double equal to working fine in Java. In Java, the strings are objects and you need to compare two strings using two methods. One is the equals method and one is the compare to method. So we are going to stick to using equals method. You can get to know more about compare to method later. And let's check. Welcome to the club. Let's submit it. Correct answer. So yeah, that's it for the first question. Pretty straightforward. You can simplify this to a single line using the ternary operation. Let me give you a slight hint about it. So you're just going to require to string these as true and false conditions, and the condition is going to be s dot equals. So if s dot equals is true, then welcome to the club will be printed, otherwise access denied will be printed. Let's quickly check this again. Okay, there is some mismatch with the brackets, I guess. Yes, this bracket was unnecessary. Welcome to the club. Let's submit. Done. So that was it for the first question. Let's move on to the second one. The second one is minimum bottles. So you can pause the question, pause the video here, go to the question, read it, attempt it, and come back. Let's continue with the solution. So this is a pretty straightforward question. Again, you are given n identical bottles and an array consisting of n items again, where ith bottle initially contains a of 5 liters of water. Now you want to carry all your water with you on a trip. You are going on a trip, let's say with your friends, and you do not want to make the packing a hassle. So you want to carry the least number of bottles with you. Now you can transfer any amount of water from one bottle to another, provided that there is no spillage. So we are going to consider that there will not be any spillage, and no bottle contains more than X liters. Water from one bottle can be transferred to different bottles if you wish to do that. What is the minimum number of bottles you can carry with you while still having all the water? I'm going to skip the input format, output format, pretty straightforward. The constraints are not so necessary here. I'll explain you why. So let's look at the question in a representational manner. Now let's consider a case where you are given three bottles with X capacity maximum each. And initially I have 6 liters in the first bottle, 5 liters in the second bottle, 9 liters in the third bottle. So in such a case, instead of considering all three bottles to my trip, what I can do is the water I need to carry is sum of all these liters, right? So 6 plus 5, 11 plus 9 will be 20, which would be the amount of water you need to carry with you to your session, sorry, to your trip. Now, how many minimum bottles do you need to carry these 20 liters to your trip? Well, if each of the bottles is 10 liters capacity, then obviously I'm going to need two bottles, right? So finally my output should look something like 2, because I can shrink all these 20 liters into two bottles rather than considering three bottles and making it a hassle for me on the trip. So that is it. What did we do? Well, we basically took a sum of all the capacities of individual water, sorry, not capacities, sum of all the amounts of individual bottled waters. And by taking the sum, since we had a maximum capacity of 10, I considered division by 10, because it is pretty obvious, I guess. I need not explain it any further. So 20 was the sum, by 10 gives us 2. That is the sum of water amounts individually. I can also say sum of array, because array will be given to me by the capacity, that is X. That will be our answer. Now, what if for a change this is 8 liters? Then what will happen? Our sum now comes out to be 6 plus 5, 11 plus 8, 19. Now, to store 19 liters, how many bottles do I need of capacity? 10 liters. Again 2, but according to our formula, what are we going to get? We are going to get 19 by 10, which is 1.9, and since it is an integer division, I'm going to get 1. But is that right? No, right? So if it is 1.9, then I need to consider 2. This 2, I can call it as a mathematical seal of 1.9, right? Now, not just for 1.9, even if the division quotient comes out to be 1.3, the mathematical seal still remains 2. So we need to print the mathematical seal of whatever the formula we have applied. Let's get to coding. So again, now here is where my template comes in help for me. I can directly start with the main logic rather than thinking about test cases always. So in the main logic, I'm given firstly n, then x. So n, I scan it, along with x, I scan it as well. I'm sorry, is this the second question? Yes. Right. So if is not required, I need an array, int array new int n for int I equal to 0, I less than n, I plus plus. Since it is a single line, I'm writing it beside. You can also write it in the next line for neatness perspective, readability perspective. But competitive coding is all about writing the code the fastest. Well, let's continue. I scan the array. Now, as I earlier mentioned, I need the sum of the array. So int, let's say total water equal to 0 initially. I need to take the sum. I need these two lines again. Just for that, I need to modify the scan statement to sum statement. So I can replicate a block, a selected set of lines using Alt Shift down arrow, and I can move this down by using Alt down arrow. So by doing that, I can replicate and move the block below. Now to total water, I need to add the what do you say, the array elements. And once that is done, I have the total water with me, I have the x with me. I need to print the seal. Math.seal will give me the seal of mathematical seal of a number. So total water by x. So that should do. Let's see. Okay, a slight miss here. Scan.next int. Okay, again, my bad. 0.0 and 3.0. Well, that is not what is expected, right? So what is the issue here? Well, the total water is an integer and x is an integer, and internally an integer divided by an integer will always give integer. So we do not want that. So we are going to typecast the total water to double, because double by integer will be converted to the larger data type of double and integer, which is double. Now, most people, what they do is they enclose this inside, that is the total water by x inside double. So that is not preferable, because again, you are having the total water and x as integers, and finally the answer will come out to be an integer. Hence, either of the parameters should be double, so that your final answer also comes out to be double, or both can be double. But also, we need to note that I need to print the integer. Well, firstly, let's see if the seal is getting evaluated properly. If it gets evaluated properly, then it's all about again typecasting. So 1.0, 3.0 expected. Just we do not want that decimal part, floating point part. So we are just going to convert it back to integer. Let's run it. 1 and 3 expected. Let's submit it. Is it for the second question? Again, you must have thought of maybe some complex solution, but this is very, very straightforward. Uh, just a logical reasoning is sufficient. Alongside knowing the inbuilt function like math.seal is a, what do you say, a head start kind of thing for you. Not exactly a head start, but an advantage, you can say. Okay, let's go to the next question, which is monster. Again, you can pause the question here, go read the question and come back. In the meantime, let me reset my code so that we can start afresh. Yes, it is reset. So the question, as it mentions, you're having some n monsters, you need to defeat all of them. Each of the ith monster will have h of I HP. HP is health points. If you are a gamer, you should be knowing it. You can attack exactly one monster per day, and only if you attack A, stat A, that is only if you attack with a power of A that is greater than or equal to the monster's HP, you can defeat that monster. So the same is explained in the next line. At the end of each day, the HP of the each alive monster increases by a fixed value x. That is, if let's say there are two monsters, 1 and 2, you defeat the monster 1. Sorry, let's take the power HPs as 3 and 5. Let's say you defeat the monster with HP 3 first, and let's say each of the monsters' health increases by 1 each time. Then by the next day, when you have to defeat the 5 HP monster, the HP of it becomes 6, because it increased by x. X we considered was 1. If x we considered was 2, then it would have become 7. So you are required to find the minimum possible value of attack stat A. You need to be able to kill all the monsters with. Note that you are allowed to kill the monsters in any order you like. Now this gives us a bonus advantage about the approach intuition. We'll get to know it. So attack stat A, you need to take it such that it can defeat all the monsters in a single hit each day. Each day again. So one monster per day. Like that I need to defeat all the monsters, but I need to take care that they should be in a single hit. So which is most difficult when you're having n monsters? Defeating the last one, right? Last one as in the one with the greatest health points. So if I am able to defeat the monster with maximum HP, then I can defeat every other monster with a single hit, right? But then there arises one small issue, that is this increasing factor X. Now, what is the issue with this? Well, let's say you're having the monsters HPs as 9 and 10. Now, in that case, you must be thinking 10. If you take a attack stat A is equal to 10, you are going to defeat the monster with HP 10 and also 9. But what if X is not 1? This time it is 2 or 3 or 5 or anything. If I take 5, let's say, the first day I defeat the first monster with 10 HP. The second day, my second monster's HP grows to 14, and 14 I cannot defeat with attack stat A equal to 10. So this time I need an attack stat of 14, because if I'm having an attack stat of 14, then I can defeat the monster with 10 HP and I can also defeat the monster with 9 HP. I hope it was clear. If there is one more monster, let's say, so initially we thought 10, but later we found out that it has to be 14. Let's take another monster of HP 7. Now, when I take another monster of HP 7, again, I need to think about the 10 HP monster, because that is the most difficult to defeat. So let's assume that 10 is my current attack stat. With that I can defeat the 10 monster, and by the time I reach the next monsters, their HPs are increased by 5, that is 14 and 12. Now again, in this day, which is taking more priority for you? Is it going to be the 14 monster or the 12 monster? Again, it should be 14 monster, because the 14 monster, let's take, instead of 7, let's take 3. That would be even more clear for you to understand. So the next day 3 is going to become 8, and the 14 monster, let's say you fix on defeating 8 monster, you can do it with the current attack stat 10. So if you defeat it, by the next day you come to the 14 monster, it becomes of HP 19. That is even more than what you want, right? But if you logically think, there is one more way out of this. Instead of defeating the 8 HP monster, you can defeat 14 HP monster. Defeating this, you are left with 8 HP monster, which you can, in the next day, it will become 13, and you can defeat it with the same 14 attack stat. Now, what did we miss here? The attack stat remained 10, but how can I defeat 14 HP monster? So I need to change my attack stat immediately to 14. Once I have changed my attack stat to 14, I can easily defeat the 13 HP monster. So what am I going to do here? In every step, I am going to pick the maximum HP monster. Once I have picked the maximum HP monster, I am going to consider that HP as my attack stat, because the question says you need to maintain attack stat greater than equal to HP of the monster. So only in this condition you can defeat the monster of the ith monster simply. And why am I always picking the maximum? Because what if the case arises like 14 and 8, and if you pick the minimum HP monster, you're going to need more power the next day. That is the hassle for us. And in the question it is mentioned, we need to specify the minimum attack stat value. So among 19 and 14, obviously we are going to pick 14, right? So I guess that is it. You can try to code this up with the current approach I have told you. And once you're done, you can again come back and resume the video. The people who did not find a way how to type it, let me help you out. So here again, you need the test case format, and my template has it ready with me. As of now, we will not look that much onto the constraints, or let's take a slight look at it. Maybe we are missing out something. The t is 2 into 10 power 5, the n is 2 into 10 power 5, the x value goes up till 10 power 9, and the h of I goes up till 10 power 9. If it is 10 power 9, then we can consider int, because we know that the range of integer comes out to be minus 2 into 10 power 9 and 2 into 10 power 9. This comes out to be the approximate range of integer. So I can consider integer here. I can consider integer here. And this is a statement that you need not worry much about. Well, it simply says that in the worst case, sum of all the n values will be 2 into 10 power 5 and it will not exceed that. So firstly, int n equal to scan dot next int. Again, the same mistake, scan dot next int. Then I am having the constant as well here, x, the constant by which the monster's HP increases. And then I'm having int array new int n for int I equal to 0, I less than n, I plus plus, array of I. Instead of array, let's take it as HP, because that's even more relevant to the current question. HP of I equal to scan dot next int. And I need to start defeating these monsters in a decreasing fashion. That is, I need to pick the maximum HP monster and I need to defeat the monsters one after another from the maximum to the minimum. So such a fashion can be obtained if I sort the array. If I sort the array, what will happen is 3 1 2 here will become 1 2 3. 10 3 2 1 2 will become 1 2 2 3 10. So we are going to get an increasing order. I'll tell you how to manipulate that. Now all I need to do is I need to start from the maximum HP monster, right? So for int I equal to n minus 1, which is the maximum HP monster, I need to continue until the minimum HP monster, which is the 0th monster, I minus minus. That is, again, if you look at it, I'm starting from n minus 1, that is the maximum HP monster. I'm coming step by step to the minimum HP monster. So what do I do next? I needed an attack stat A, right? Initially, what did I consider my attack stat as? My maximum HP monster HP. So that will be my attack stat initially. If my attack stat is greater than or equal to HP of I, then I can defeat that monster. I need not change my attack stat value. But what if attack stat is less than that? If attack stat is less than that, then my attack stat value has to be updated to the new HP, because now the current monster is the monster I need to start defeating. And I need to increase the second monster's HP by X. And what will be the requirement to increase the third monster's HP then? I'm going to attack the third monster 2 days from now. So I need to increase it by 2x, right? Well, how do I make sure I increase x, 2x, 3x, 4x, 5x? All I can simply do is I can take another variable, let's say days equal to 1 initially. On the first day, I'm going to increase x HP. On the second day, I will increase 2x HP. So HP of I plus 1 is equal to HP of I plus 1 plus days into x. But not DP, my bad, HP. But here there is a trouble. I need to think about I plus 1. It's not even I plus 1. The next monster is I minus 1 monster, because we are coming in a reverse fashion. So I need to think about I minus 1 monster, which is a bit of a hassle for me. Well, let's think in this way. Now, when my attack stat is HP of n minus 1, by default, can I say that I'm going to defeat the first monster? Yes. Now, I need to start defeating from the second monster. And for the second monster, I know that I need to increase its HP by days into x. because as of now days is 1 and into x will be the amount of HP I need to increase. And once this is done, the second line is not even required. The if condition still stays there. If A is less than HP of I, then my new monster set becomes my attack stat. And once the entire process is done, then I need to move to the next day, so days plus plus. And with all of this done, yes, we are done. Finally, we need to print the attack stat A. Let's print and check. Okay, this should be arrays dot sort. My bad. 21 and 10 expected output. Well. 4 cases have failed. 1 is the wrong answer and all the others got skipped. But 3 cases are correct. Well, in such cases, there are 2 possibilities. And the major possibility could be because of the constraints. There must have been something very slightly missed thing from the constraints that must be causing this. If the constraints are taken care of, then there should be a logical issue. If it is a time limit exceeded, you need to think on optimizing the solution. If it is wrong answer, then you need to think on any edge cases that you have missed. Let's see what we have missed in the constraints here. Well, one thing we have missed in the constraints is the HP is given 10 power 9 and the X is also given 10 power 9. In such a case, what will happen on the third day for the third monster? For the third monster, sorry, what will happen on the second day on the third monster? Uh, 10 power 9, 10 power 9, 10 power 9. Let's consider 3 monsters. X is equal to 10 power 9 again. You defeated the first monster, the second monster became 2 into 10 power 9. The third monster should also become 2 into 10 power 9, but programmatically we are not computing this yet. So let's leave that 2 into 10 power 9. Now you will make this as your new attack stat. You will defeat this monster. Coming to the third day, you are defeating a monster of HP 3 into 10 power 9, but our integers range is 2 into 10 power 9. And this is where we are missing it. And we need to take it as a larger range, which is long. So what needs to be changed to long? One thing is HP. Well, if you do not want to change HP because HP is alright, you can see that going forward the HP's elements will get changed to a value that is outside the range. So yes, you need to change the HP values to a long array. Next long, and everything else remains the same except for the attack stat. The days is not going to exceed because the max number of monsters is 2 into 10 power 5. You must be thinking, why will long work? Well, it is because in the worst case you are going to go until 2 into 10 power 5 monsters defeated, that is 2 into 10 power 5 days. 2 into 10 power 5 days, initial value of 10 power 9. If you sum it up, it is not going to exceed 10 power 18. Going forward, anything else required here? Nothing else. Well, there is one more issue that my x into days is what might exceed the limit as well. So this also has to be changed. Well, we'll do a typecasting here. We'll do a typecasting here. Let's run it and check. We have just only done data type changes, but it is better to do a run check and then submit instead of blindly submitting directly. Okay, time limit exceeded. Well, what could be the case here? One thing that is costly that we are doing here is this typecasting. Let's try to remove that and check if it works. And as I earlier mentioned, int by int is int, right? The same way int into int is also int. So if either of the data types is long, then the default answer value also becomes long. Let's just submit it. So one extra learning here for us is typecasting is a bit expensive and might even exceed the time limit at times. Now let's go to the next question. Crazy jumping frogs. Again, the same pattern. You're going to pause the video here. You're going to go check the question, try it out, and come back here. So the question is a bit tricky over here. Give the question a proper read. Well, it says that you are given n frogs numbered 1 to n. There are two n buckets numbered 1 to 2n, and you are given an array A of I denoting the index of the bucket containing the frog I. You are given the initial values of A of I. Every second the following thing happens. I'm not going to explain that. Just give it a proper read, you will understand it. Basically, if there are if there are three frogs, let's consider, all these frogs will move to the frog that is numbered the least. Now you might be thinking, what about the frog that is numbered the least? Where will that move? Well, that will move on to the frog that is numbered least other than itself. So I'll explain it to you in a representational fashion that will get you a bit more clarity on the question. And you need to note one thing very specific, that all these movements are done simultaneously. So you can see the below examples for further clarification. Your task is to determine the largest number of frogs in a single bucket at any given point of time during this process. Well, he has mentioned this point very cleverly because he knows what will happen internally, which is infinite loop. He mentioned here this will continue infinitely. So let's just uh, try it for an example. And they have given 2, 1 and 3. I'll explain you what 2, 1 and 3 means. Now the given array is 2, 1 and 3, which means he has mentioned 1 based indexing. So I'm taking a 1 based indexing, 1, 2, 3. Or let's take a 0 based indexing. Maybe that will not confuse you. So 0, 1, 2, the 0th frog is in the second bucket. He has told that for 3 frogs there will be 6 buckets, right? So let me take 6 buckets, 3, 4, 5, 6. But he has mentioned only 3 buckets usage. So that is the second frog is in the, sorry, 0th frog is in the second bucket. Again, here he has mentioned 1 based indexing, so do not get confused. The 0th frog is in the second bucket, the first frog is in the first bucket, and the second frog is in the third bucket. So 0, 1, 2 is our initial position. Now what might happen here? Well, the 0th frog jumps to the smallest frog among all the other frogs, which are 1 and 2. That is 0 jumps to left. And whereas all the other frogs will jump towards the smallest frog, smallest numbered frog. So 1 jumps towards right, and 2 jumps towards left, and 0 jumps towards left. I hope you understood why 0 is jumping towards left, because other than 0, the frogs are 1 and 2, and among 1 and 2, 1 is smallest. So 0 jumps here, 1 jumps here, 2 jumps here, which means 0, 1, 2. Now 0 is going to jump where? It is going to jump on to where 1 was. So it is going to jump onto its right side, and 1 and 2 will now jump onto left side, because again 0 is the smallest numbered frog. So the next step will be 1 to 0. Then this will keep on going 0, 1, 2 infinitely, and that's what he mentioned over there as well. Now at any point here, well, you can see that until here only you are going to get individual, what do you say, states that are not repeating, not individual, non-repetitive states. Beyond this, all are repetitive states. So until this point, if you consider the entire process, it is going to be sufficient. Now, let's not think about it programmatically. Let's think about it logically. Programmatically, yes, you will be having trouble finding out if it is repetitive state or not. So what can we do is, we can think of it logically. Let's see how this can be solved logically. Now The second test case they have given here is, okay, before going to the second test case, we'll firstly get the answer for this. If I, as I mentioned, non-repetitive states, if I consider until here, at any point the buckets, the maximum number of frogs in the buckets is 2 frogs, so my answer is going to be 2, and that's how the expected answer here is also 2. So let's understand this with the second test case, but second test case is something like this, and is a very troublesome thing to trace out, dry run and find out. So we'll take simpler couple of cases. I'll do the first case for you. You can try out the second case and try to understand what will happen. Or let's do it the other way around. Take the first case as your to-do kind of thing, and I'll solve the second case for you. Now the second case is, you are given 5 frogs, which means there are 10 buckets. I'm not mentioning these as bucket structures, but I hope you understand. So let's trace the second case and try to understand. 5 moves to the right, 3 moves to right, 2 moves to right. 1, where will it move? Other than 1, the smallest number frog is 2. So 1 moves towards 2, that is to the left, and 4 moves to the left. So 4 groups along with 2. Now one more step ahead, 5, then 3, then 2 and 4 will move to the right, because, sorry, 2 will move to the left because it is 1. Sorry, 1 is over left. That is, along with 3, we also get 2 and 4, and 1 moves to the right because it has to go towards 2. Now going one more step forward, 5 here, 1 here, 3, 2, 4. One more step forward, 5 moves to the next point, 1 moves to the next point, 3 to 4 move to the left because towards 1. So 3, 2, 4, 5. And beyond this, it is just an infinite. So instead of thinking, how can we simulate this? Let's think of it logically. Well, let's look at all these elements, 3 to 4, 5. 3 is at 6, 2 is at 8, 4 is at 10, 5 is at 4, 1 is solely at 9. What is the commonness among all these 5, 3, 2 and 4? They are all in even bucket numbers. What is the commonness with 1? 1 is alone. Well, if the other frogs are in even numbered buckets and evens opposite is odd, 1 is going to be in odd bucket. That is the only difference you can find among these. So you can try the same thing for the second case given over here, and you will reach to a similar conclusion. Now, what is the conclusion? All the even bucket frogs will definitely group together, and all the odd bucket frogs will definitely group together, because let's consider a very simple case of 1, 2, 3, 4, where the frogs are in buckets. 1 is in the second bucket, 2 is in the third bucket. Now 1 always goes to where 2 is, 2 always comes to where 1 is. So in the next step it becomes 2, 1, in the next step it becomes 1, 2, in the next step it becomes 2, 1, and infinitely. Now what happened if 1 is in even bucket and 2 is in odd bucket? They never really meet at all. But what if 1 is in the second bucket and 2 is in the fourth bucket? Then the next move itself, 1 and 2 will group together. And why is that so? Because they are in same parity buckets. Parity as an odd or even parity. You can consider the same thing for 1 and 3. In the next exact move, 1 and 2 will group together in the second bucket. And why is this happening? Because even bucket frogs will eventually group together when they keep moving on to the final state. Odd moving frogs will definitely group together when they are moving on to the final state. This is a pattern kind of thing, and we have seen with examples here, And a fact that we have recognized here is only even buckets frogs can group together and communicate, not communicate, group together, yeah. And odd bucket frogs can only group together. So ultimately, at the final point, you'll have two buckets. One is the even bucket frogs, one is the odd bucket frogs, and beyond that, it is infinite. Now, I need to know what is the maximum number of frogs in the buckets, right? There are only two buckets, even numbered bucket. Let it be anything, we do not worry about it. And there is an odd numbered bucket. Let it be anything, we do not worry about it. We just need the maximum among the odd bucket frogs, the even bucket frogs. So here I'm going to get the answer as 4. Let's, without any further ado, go for the code part. So this is a pretty straightforward code. Going forward with the code, I'm just going to get the n value and the n integers representing the bucket numbers. So scan dot next int, then I need array of I, scan dot next int for int, sorry, not array of I, not scan dot next int, new int of n for int I equal to 0, I less than n, I plus plus, array of I equal to scan next int. And what else? After scanning, I just need to know how many even numbered bucket frogs are there, how many odd numbered bucket frogs are there. Odd equal to 0 initially, even equal to 0 initially. For int, it is the same above lines I need, so alt shift down arrow, alt down arrow. And if the current bucket is odd, that is array of I is the bucket number. If it is odd, not equal to 0. If this is true, then odd plus plus, else even plus plus. And finally, among all these odd bucket frogs and even bucket frogs, I need the maximum. So math.max of even and odd, and that is it. Nothing else is required. Since it is count of frogs, you need not worry about the, what do you say, the integer long values. And that is it. And this was about CodeChef Starters 170. So that's it for today, guys. I hope you liked the video. Thanks for sticking by until the end. If you found this video helpful, share it with your fellow coders and help them solve the problems as well. To stay updated with latest coding contest solutions, hit the subscribe button and let us know in the comments what other content you would like us to make. Until the next time, keep coding, keep improving.